Hi everyone, this is Chitra. I'm here to explain how to solve a center of a given asymmetrical figure. Firstly, center of a body is a point at which the whole area of a body or plane figure is assumed to be concentrated. Centroid and center of gravity are the same point. With respect to x bar, we are going to calculate summation of a into x by summation of a. To get y bar, we are going to calculate summation of a into y by summation of a. And here comes our question, find the center of a given asymmetrical figure. And we don't know the exact center of the given figure, so we are going to divide it into known components, like known center components. We know the center of a square, rectangle, and center of triangle, center of quadrant, semicircle. So finally, dividing this figure to a known component, we get four known components. One is semicircle, second one is triangle, third one is square, fourth one is rectangle. We are gonna calculate separately the x and y. Firstly, we take semicircle. Semicircle area is pi r square by 2. Looking to the figure, radius is 10. Substituting it, we get 157.07. And y bar is distance is 4r by 3 pi. And it is 40 mm far from x-axis. Adding it, we get 44.2441. Multiplying a into y, we get moment of x-axis. And next is centroid distance from x-axis, that is nothing but x. And d by 2. D by 2 is nothing but r. Our radius is 10, so d value will be 20. D equals to r square. So 20 by 2 is 10. Again, it's 20 mm far from y-axis. We are going to add 20 plus 10. We get 30, and we're going to multiply a into x. We get moment of area about y-axis. And let's take the second component is square. And center of square is a by 2 with respect to x bar and y bar, as all the sides are equal. And a square, we get 40. Centroid distance, that is y, is a by 2, and it is 20 mm far from x-axis, so we are going to add 20, so we get 30. And it's same, 20 mm far from y-axis, we are going to add a by 2 plus 20, we get 30. And for moment of x-axis and y-axis, we are going to multiply a into y and a into x. And third component is triangle. The center of triangle is not exactly at center, it's close to a 90 degree, like b by 3 and h by 3. And area is of h into b, of into 20 into 20, we get 200. And centroid distance from x-axis, that is y, it's h by 3, and it's 20 mm far from x-axis, so we are going to add 20, we get 26.666. To get moment of x-axis, we multiply a into y. And now we are going to calculate moment of centroid distance of y-axis, that is 2b by 3. As we know b by 3 value, and remaining distance, obviously it's 2b by 3, so it's 13.333. To get moment area of y-axis, we are going to multiply a into x, that is, so the value is 2666.6. And our fourth component is rectangle. Area of rectangle is breadth into depth, 14 to 20 is 800. And centroid distance of y is 20 by 2, it's 10. And we are going to multiply a into y, we get moment of x-axis. And b by 2, to get center of y-axis, it's 40 by 2, it's 20. And moment of area about y-axis, we have now multiply a into x, so we get moment of area about y-axis. And overall summation of area and moment of x-axis and moment of y-axis, we are gonna add, as there is no component to be separated, so we are gonna add all the components. And finally we get x bar, y bar. X bar value is 19.63 mm and y bar is 17.04 mm.